Welcome to the forces tutorial. A force is a push or a pull, and while that definition may not seem very scientific to you, it works just fine for our class. Any push or pull that you feel is caused by a force, and there are only 4 fundamental forces that make up all the pushes and pulls in the universe. And it gets even better, we're going to stick to just talking about 2 of them for this part of the course. Gravity, on the left-hand side, is the force that you're probably most aware of, right? That's the force that seems to you, probably, to be the strongest force you've ever encountered. But actually, gravity is quite weak compared to this other force, which we're going to talk about now. Electromagnetism is the force that you feel whenever 2 objects come in contact. Whether you're pushing or pulling on the other object, or it's pushing or pulling on you, you're feeling electromagnetism. And electromagnetism exists because all matter is made of atoms, and atoms actually have electric charges in them, or we can also think of them as magnetic pushes and pulls within them. Electricity and magnetism are actually part of the same thing, and wherever electricity goes, there's some magnetism following it around, and wherever magnetism goes, there's some electricity hiding in there too. And it may not seem obvious to you when you pick up a magnet that there's an electric current that magnet can create, and it may not seem obvious to you that an electric current can affect a magnet, but it can. The 2 things are related to each other. However, you don't need to know much more than this. You just need to know that all the matter in the universe is made up of atoms, and all of those atoms have a kind of electromagnetic push-pull relationship with all the other atoms in the universe. Think of it this way. Every atom is like its own little magnet. And you know how magnets are. Sometimes they push apart and sometimes they pull together, depending on how you hold them. Well, that's true of all the atoms in the universe. Sometimes they pull each other together, and sometimes they push each other apart. Now you might be thinking, wait a minute, gravity's way stronger than any magnetic push or pull I've ever felt, Mrs. Draguzzi. And that's true, except that's only because electromagnetism only happens over a very, very short distance. 2 objects have to pretty much be in contact before their atoms can either push apart or pull together. But gravity happens over a really, really huge distance. You can feel the gravitational pull of the Earth a good mile or so up into space and even further. And so gravity is thought of as stronger, but it just takes place over a longer distance. In truth, if gravity were stronger than electromagnetism, then you would not be able to sit in your chair or stand on the ground right now. Gravity would pull you right to the center of the Earth. However, that's not happening because some object is actually preventing you from continuing to fall. And that object is doing it with the electromagnetic force. It's pushing back against the atoms in your body with the atoms in the object you're sitting on or standing on. So therefore, the electromagnetic force must be stronger than gravity. If it weren't, you'd be falling straight to the center of the Earth right now. Now, electromagnetism actually comes in different flavors. We could name the different forces that are really electromagnetism lots of different things, but I picked these 3 different subtypes of force: friction, the normal force, and the applied force. So let's talk about each one and when you see that force acting on an object. Friction is probably a pretty familiar force for you, right? If you take your 2 hands and rub them together, you can feel the force of friction. It's a type of electromagnetic force, which I've abbreviated as EM, and all friction opposes the direction of motion. So if an object is moving and it's experiencing friction, it's basically being slowed down or stopped by that object, by that friction force. And it's caused by attractions between molecules in one substance that's sliding over another. So this is an attraction between atoms, right? So we said before that atoms and the electromagnetic force can be both attractive and repulsive. They can push apart or pull together. And with friction, it's a pulling together. Here's a little picture showing friction between a road and a tire. And you can see that if you look closely at the tire and the road, the surfaces are not completely smooth. They actually have lots of little nooks and crannies and little bumps. And those little nooks and crannies, if you could take a microscope in there, and a really, really powerful electron microscope, you'd sort of be able to see the contours of the atoms. You wouldn't actually see atoms, but you'd see sort of their outlines. And you can see that over on the right-hand side in the yellow box, I'm showing you that these atoms are actually attracted to each other. As the tire is moving over the road, there's these momentary little attractions between the blue road surface and the green tire surface. And the more nooks and crannies you have, the more likely it is that the two surfaces are going to have a chance to get attracted to each other. And that's because if the surfaces are flat, there's less surface area and therefore less opportunity for atoms to come into contact. So this is why rougher things have more friction, right? You kind of instinctively know that the more rough a surface is, the more friction it has. This is why the ice down here is not a very good surface for stopping a polar bear, because the polar bear's fur and the ground's ice are both pretty smooth surfaces, so there's very little friction there. There is some, however. The next type of electromagnetic force that I want to talk about is called the normal force. And the word normal actually refers to a 90-degree angle, and you'll see why in a second. The normal force is caused not by attraction between atoms, but by repulsion, by atoms that are pushing apart. That's what it means to repel. And a repulsion is what happens when two things repel each other. They are repulsed. So this occurs whenever two objects are in contact with one another, and the direction of the normal force is always perpendicular to, or at a 90-degree angle to, the surface. So if you look at this guy on the slide in the red shirt on the top of the slide, the force of gravity is pulling him down, and the slide is holding him up because his butt and the slide are in contact. And at that point of contact, there's a normal force. The slide's atoms are actually pushing up against the atoms in that guy's behind. And that is what's holding him above the ground. Notice that the normal force is perpendicular to the, whoa, always do that, sorry. It's perpendicular to the surface, right, where they're in contact. So the slide surface is directly across where I just drew it, and the normal force is perpendicular at a 90-degree angle. That's why it's called normal, because it's at a 90-degree angle, and that's the normal angle. Notice the guy in the yellow shirt, however, the slide is no longer straight across, the slide is at a tilt. But that means the normal force is not straight up and down. Now the normal force is going up this way at a 90-degree angle to the slide. So even though gravity's pulling him down, he's no longer in balance with gravity. That's why he's moving. The normal force is actually has the same force that it had before, but it's being pushed off in a different direction. And so the guy in the yellow shirt begins to slide down the slide, whereas the guy in the red shirt is held up against gravity by the fact that the normal force is in the opposite direction of gravity. And anytime something slides down a ramp or a slide or anything like that, it's because the normal force is now at an angle relative to gravity. And finally, the last version of the electromagnetic force is the applied force, and this is the force that is given by a person or another object. So it's a type of electromagnetism. This is the atoms of one object pushing or repelling the atoms of another object. Typically an applied force is put on by a person, so this person is pushing this block, but it could also be something is knocked into something else, one object hits another object, or a motor is running and pushing something. All of those things are applied forces. And they're also caused by repulsions between atoms. So you have three types of electromagnetic force that we've discussed. We haven't really discussed gravity. I want to save gravity for its own separate tutorial because gravity is actually fascinating and I want to spend a little time on it. But you're familiar enough with gravity that you recognize it when you see it. So your goal here is to make sure that you can identify the three different types of force, particularly in pictures. So if I were to show you a picture and tell you a little story about the picture, you should be able to tell me where you see friction happening, where you see an applied force happening, and where the normal force is happening, and in what direction it's happening. And we'll do practice together in class. Okay, see you in the next tutorial.